exponential function, this is all a logarithm is. Okay, typically what we're trying to find in the logarithm, though, this is what we would call its exponential form. Usually when I evaluate a logarithm, the unknown is what we're looking for is what is the exponent itself. So the way we write a logarithm so that it's the y isn't up in the exponent is we say that y is the logarithm, and the abbreviation for logarithm is log, and the base, it's like a subscript, it's base b of x. So these two things both represent a logarithm. This is what we would say is the log form. This is the exponential form. So that's really all we're doing today. So the problem becomes, though, because we can use our calculator to check things, but the problem becomes when people really don't have a knowledge of exponents, but I think you guys do. I think we've been talking about it an awful lot. So the question you're going to hear me say a lot today is, what is the exponent, or what is the power of such and such? Okay, so what I mean by this is, if I asked you what the log base 2 of 16 is, I'm asking you, hey, what power, what exponent would produce the result? Okay, so if I say, what's the log base 2 of 16, what do you think that is? Well, 2 to the first is 2. That would be 4, right? Now we're at 8. 2 to the fourth. So what's a way I could check my answer? I could check my answer by just doing the exponential form and checking that it works. Okay, so what we just found is, okay, I think that's going to be the hardest thing for us, is like, this is like, what does that statement mean? Okay, so what I'm saying is 2 to the fourth is 16. That's how I write it as a logarithm. As an exponential form, what does that mean? It means 2 to the fourth equals 16. And when students are rewriting, here's what I teach them. Do you see this base down here? We call it the base of the logarithm, okay? It's like that subscript. That always is going to match the base of my exponent. When I'm trying to figure out what the exponent is, it's always going to be on the other side of the equal sign, and where I see that is up here. And then what's remaining on this side goes right here. Okay. So I think what I'm going to do is I'm going to write that right up here, okay? The log form would be log base b of x equals y. And the way I write that as an exponent is b to the y equals x. Okay, so on your paper, let's just practice some, okay? Let's rewrite the following in exponential form. Okay, so how about if I had, we're going to do log base 3 of 81 equals 4. We're going to say log base 5 of 25 equals 2. Log base 2 of 1/2 equals -1. And the log base 9 of 3 equals 1/2. All right. So, looking up here, the base of my log, we're going to write as the base of the exponent. So what's the base of the exponent here? It's just a 3. The exponent, that is that y there, we find on the other side. What's the exponent here? Isn't it 4? Equals 81. These are all true statements. Isn't 3 to the 4th 81? Okay, so we're just practicing rewriting it in exponential form. All right, this one. This would mean that 5 to the 2nd equals 25. Just confirm, isn't that true? 5 to the 2nd equals 25. Okay, the next two are kind of special exponents. Okay, these are ones where we've learned and studied them before, but they're a little bit different. This would mean that 2 to the -1st equals 1/2. Isn't that what a negative exponent means? Yeah, when we do 2 to the -1, that means to take the reciprocal, 1 over 2. Okay, so flip it around. And then this one, 9 to the 1/2 equals 3. Isn't the 1/2 exponent a square root? Yeah. Okay, so the square root of 9 equals 3. All right, let's go the other way. I think this way's harder, but maybe not. So this time we're going to take some exponents and we're going to rewrite them in logarithm form. Let's just do like 3 of them. How about 7 to the 3rd power equals 343? And let's do, what's one we haven't done yet? 4 to the 2nd power equals 16. Okay. Yes. I forgot the what? Oh, here. Thank you. 4 form is what I meant. Thank you. All right, so the key thing here is all of these are going to start with log. And then the base is going to be the base of my exponent. What is the base of my exponent here? Not the exponent. What's the base of the exponent? 7. So this is going to be a log base 7. Okay. What's this one going to be? This is going to be a log base 4. Okay. So the base of the exponent is the base of the log. Okay. Next, this is where it flips around. We are going to put here the result, what's on the other side of the equal sign. So this is going to be a 343. And on here, on the other side, is always what is the exponent. And the answer to that is it's 3. So what does this one mean? The log base 4 of 16 would equal 2. Okay, so that's kind of first. The next thing I would like to do is, and this is the thing we're going to need practice with, if you need a calculator, grab a calculator to check your answer. And what I mean by that is, We'll talk about these two, log and ln. Do you guys remember what the guy in the video said log was yesterday? What the base was? If you remember, I'm going to be really impressed. I'm very impressed. Yes, this is a base 10, and this is something called base E. We're going to talk about all those things later on. You can't use this to evaluate these logarithms, because these logarithms are all other bases. But what you could do is you could check your answer. Like if I was like, 3 to what power is 27? And you're like, oh, I think it's 3. We could check it. Oh, that's 2 to the third. We could check our answer by plugging it in our calculator that way, since we know it's exponential form. All right, let's try some together, and then we're going to whiteboard for the rest of the time. Okay, so we're going to evaluate each logarithm. So if I had, if I asked, what's the log base 8 of 64? Let's do log base 8 of 1 over 8. And then let's do log base 8 of 8 to the 5th. Okay. So what I like to do is this is what we're trying to find, right? I'm putting a little question mark here. I like to write what we're really doing just in case, you know, you're like, what are we doing now? Okay, this is the base, right? I am trying to figure out 8 to what exponent gives me 64. What is the answer to that? 8 to what exponent or what power gives me 64? 2. So the answer to this is a 2. Okay. All right, this is asking, you don't have to write this down. I'm just so you're understanding, like, how are we getting these answers? 8 to what exponent gives me 1 over 8? Well, since it's 1 over, it's going to have to be a negative exponent. And it's the same number, right? So it's just a negative 1. Then, this is something interesting that I want you to notice. What if I write it as an exponent of 8? Then I'm saying 8 to what exponent is 8 to the 5th? This is kind of a no-brainer. Isn't the answer right in front of you? 8 to what exponent is 8 to the 5th? It's just 5. This has to do with the fact that I said logarithms and exponents are inverses. They undo one another. Okay. All right. So that's the kind of thing we're going to be spending some time on.